bring on board my yes. Sorry for the setting of my this. But I promise you everything is going to be all right. Okay. Sorry, I have to share to my student first. We are on the same page now. Welcome back to my YouTube channel. Today I will just be revolving around some basic things that you need to know as a student, preparing for any of these forthcoming exams, being JAMB, JUPEB, WAEC. Just name them. So please, I'm going to, sorry, because of this thing. I just have to. All right, so now, just like I said, revision on an organic chemistry. Yeah, we are going to do it in such a way that by the time we are done with what we're supposed to achieve today, you will know what you yourself have covered and how exam ready you are. Now, normally, this is not a time to come. I've been defining all this concept in order of the live session we have been having. I told you organic chemistry is the chemistry of what? Carbon atom, or chemistry study of carbon atom, with few exception of certain, compound of what? Carbon. What do we mean? Organic chemistry is simply the chemistry study of carbon compounds. You know what compound is in chemistry? Right from the elementary on the introductory aspect, after definition that chemistry is the what? Study of matter, its composition, properties and uses of matter. Then we start talking about changes that take place in chemistry, being chemical change and physical change. And you see chemical change lead to the formation of new substance, and it is not easily reversible, whereas physical change does not lead to what? Formation of new substance, and it is easily reversible. But that aside, I'm just saying this to say that since we talk about that chemistry study matter, before we delve much into that, remember I mentioned matter. Now you already know that matter is anything that has mass and occupies space. Are you seeing it now? And in chemistry, we can talk about matter being homogeneous and what? Okay. Let me not go there. Then you can talk about matter in chemistry being or matter is otherwise known as substance. Matter is otherwise known as substance. So we can call it, we can have what we call pure substance or pure matter, pure substance. Sorry, I have to just show you something before we go. It's still part of the revision. You can have pure substance or pure matter, and also what? Impure substance or impure matter. I told you, substance in the sense that I have a definite or maybe composition and all that, but let's not there. I just want to pick something here, then we go back to where we're supposed to be. Revision on organic. Now, you can see pure substance noun are simply your what? Element and what? Compounds. Are you seeing it? Why this is simply your what? Mixtures. And then it is this mixture that can be splitted into homogeneous mixture, homogeneous, meaning they have same composition throughout, and then what we can call heterogeneous. Of course, homogeneous mixture is otherwise known as your solution. That is why there was a question I asked yesterday, the difference between compound and mixture. I did the video. Of course, I also drop it down as a question challenge, because you see, you need to practically equip. How will I say, when I say practically, like by virtue of reading, studying, and discovering new things, equip yourself. This exam are just exam that requires your technical know-how, your ability to reason beyond others. That is why, of course, you shouldn't do things the way you have been doing it to have same results. You set a target and see yourself achieving it. Heterogeneous mixture. This one have same composition. That is why we call it solution, which is mixture of solutes, and solvent. Why this one you will see partition that they are not actually of same making. But that aside, we are going somewhere. All these things is just something we are going to be taking gradually, and that is why each and every now and then, please do well to understand. You are not just coming here, you are coming here to learn, not just maybe to, see for sightseeing and all that. I'm going to increase my handwriting. I'm trying to observe and also to just how I position my boards. It is well, but everything is going to be all right. I promise you. Everything gonna be all right. I will increase my handwriting for you to see it very well. Don't forget, I say we have what we call pure substance or pure matter. There is what we call percentage test for purity. I'm going to take this as a topic. We are going somewhere. Organic chemistry is no other thing than the chemistry study of. We are doing revision. I wish maybe you join my last session or the sessions I've been having, about 3 different sessions now that I've been having on this media space. You will know that, okay, the revision really worth it. So that those things that I've taught thus far will sink deep. Yeah, it will sink deep. Now, one of the things you will do for me whenever you're in this space with me, keep sending reaction to my video so that others can easily discover it. But there are so many people that need these services. Not just that, do well to subscribe, because there's exclusive benefits to all my active subscribers. That being said, I want us to go straight to the point. We are here to discuss on matter and all that concerns matter. Sorry, I'm looking for my this thing. Oh God, where did I drop my stuff? Okay. Sorry. Okay. So we're going straight to the point now. Sorry about that. Sorry. Okay. Yes, I hope you can still hear me. Yeah. Sorry for the distraction. Now I think we are good to go. Now let's talk about matter and matter related. Sorry. Okay, let's talk about matter and matter. Let's talk about organic chemistry. What is this? Yeah, I told you organic chemistry is the chemistry study of carbon compounds. Whenever we talk about organic, yeah, let me put it this way, organic chemistry, it is all about carbon. It's all about carbon. Yeah, it is a chemistry study of carbon compounds, with few exception of certain compounds of carbon. And what are those compounds of carbon that is an exception to the definition of an organic chemistry, or to what organic chemistry encompasses? One of them is what we call the what? Oxides. Another one is what we call the carbonates. Another one is what we call the what? Bicarbonates. All these are compounds of carbon that is rather being studied in what we call inorganic chemistry. Then another one is what we call remember I mentioned oxide, carbonate, bicarbonate. We have carbides of metal, carbides of metals. Carbides of metals. Another one, compounds of carbon that is not organic, is sulfides. I mentioned this before, but this is a revision hour. Sulfides of sulfides. Yeah, sulfides of, that is non-metal now. Your sulfide, your put sulfide. Now, of course, there are two oxides of carbon. We have the CO and CO2. This one is what we call neutral oxide, as the other one is what? This CO2 carbon 4 oxide is acidic oxide. Take note, this is neutral oxide. No, when it's not just because, most especially when we are doing revision, if you allow me to revolve around, tell you in case I hit it, I hit on something, then I should be able to tell you other things that you need to know. Because you see, your exam is all about how much you know. I see how much you're able to retain. Now, it's not who cover book, and that is why you read with precision. Yeah, precision and accuracy. That is just it. Read points. Read something that will come out. Nobody will say because you have covered this thing so number of times and even though you don't understand it. No. When question come, that is what shows whether you are on point or out of point. Take note of that. Take note of that. Sorry. Let me just remove this. So that is what shows whether you are on point or out of point. So you can see sulfide. I mentioned carbonate. What are the carbonate? Carbonate here you have cacoteri. Cacoteri. That is this limestone. Yeah. Bicarbonate you have calcium hydrogen carbonate. You can have something like this. Let me see. Yeah, something like this. Something like this. Yes. You can have something like this. Now here you have carbide of metal, calcium dicarbide, CaC2. Of course, this one, carbon disulfide or carbon 2 sulfide, CS2. All these are compounds of carbon that is not organic. Are you seeing it now? There are compounds of carbon that is what? Not organic. Now, please, if you are still here with me, do it to keep sending reaction to the video. There are actually compounds of carbon that is not organic. You need to take note of that. Okay. Having said this, then we need to talk about, don't forget, I mentioned there are some unique properties of carbon that make it the central atom of an organic chemistry. There is something, or there are things that make carbon the central atom of an organic chemistry. And one of those things that you have to pick is what we call catenation. Catenation, unique essential ability of carbon. We mentioned catenation. This is a revision session. I don't have to write too much on the board. Now, because we are going to be solving question, I will drop question and describe it, you understand, from the beginning. And with this, I promise you, it's going to make sense at the end. So catenation is not that thing done. The ability of a carbon atom to form multiplicity of bonds with itself and other elements. Catenation. Very necessary. Catenation. Catenation. The ability of a carbon to form multiplicity of bonds with itself and other elements. That is what we call catenation. Now moving forward, you see there is also another thing about carbon, the tetravalency of a carbon atom. Before you even know how to name and what is obtainable as far as carbon is concerned, you must understand all these things. Now, as I mentioned catenation, you see carbon can either form carbon-carbon single bond, or there can also be presence of double bond. Are you seeing it? In a carbon. And now look at this. Each carbon must always have 4 bonds pointing to it at every particular point in time. That is what we call the tetravalency. It is tetravalent covalently bonded. Because the type of bond is covalent bond, shared bond. No ionic, one transfer while the other one receive. All this bonding, I'm going to take it as a topic, but you need to understand one or two things as far as this is a concern. Now, the same thing if you go to triple bond. Each one, look at, they have these 3 bonds shared, and this one complete. 1, 2, 3, 4. 1, 2, 3, 4. Each carbon must have 4 bonds pointing to it. Now, at times when they give you a compound, know whether if the compound is even realistic. You can't have something like this, and this, and this, and this. It's not possible. Each carbon here have 5 bonds. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. It is not possible in a carbon atom. Because if you understand this basic thing, then it becomes practically easy for you when a question is, there's no question Well, by the grace of God, let's say I think we should. I don't want to engage much in talking. I want us to engage very well in doing, so that you will use your eyes, see things yourself. You see the reason. By the time we clear all these little doubts, what have been making you not to really grab the question the way it's supposed to be, you will see it. And that is why I'll keep admonishing you. In as much as you join me here, please do well to subscribe to the channel. Not just that, also drop okay. Oh, someone education say 5 bond aren't okay. Thank you very much. That is true. Yes, yes, yes. There is not. It's not possible to have 5 bond in a carbon atom. That is what I'm trying to say. Yes, it's not possible. So keep sending reaction to the video as you are going somewhere, and don't get tired, because today we are going to definitely dissect a whole lot of things. Those things that have been giving you tough time, just name them and get ready to receive majority or see most of them being solved. Now, let me concentrate here now. Of course, we have mentioned some basic things about carbon. Yesterday, I told you there is what we call hybridization. Yeah, in our live session, I say hybridization is the reshuffling, the blending together, the mixing of what orbital of same energy level. Orbitals of same energy level. Let me show you something quickly. You know, a carbon atom being the center, or a carbon being the central atom of an organic chemistry, is what is being hybridized. And you shouldn't forget there are just 3 types of hybridization that a carbon. There are so many different type of hybridization: sp3d, sp3d square, and other ones. But that is no longer for carbon atom. Are you seeing it now? The type of hybridization carbon undergo is sp3, sp2, and sp. Are you seeing it now? Now, okay. Let me show you something. In electronic configuration, please permit me. Yes, I said that whenever I come live session again, I will explain the concept of what electron. You know, we call it in chemistry still somewhat part of structure and bonding. Organic chemistry like that. There are basic concepts that you need to understand before even delving much in all this. So this one is this one is that. Talking about functional group being that part of an organic chemistry where most of its chemical reaction do usually occur. I'm not when it is something for you to take note, I won't be fast. But if it is something that I know that we're still going to do over and over again, no, just calm down. Now, let me calm down and show you something. You know, just like if I mention carbon, which you know the atomic number is what? 6. Of course, atomic number is the number of protons in the nucleus of an atom. Are you seeing it? That is atomic number. That is why another name for atomic number is proton number. Just like when we say mass number is the sum of proton and neutron in the nucleus of an atom. That is just it. And of course, you know that an element is said to be electrically neutral when the number of protons equal to the number of electrons. So, but that aside, we are going to be doing that under atomic structure. Hold me by my word. And even these things I wanted to do, let me still reserve it on atomic structure, so that we tell you 3 basic principles. Let me just quote them. 3 basic principles for ascribing or assigning electron across the various orbitals. This is not the first time you heard of SPDF. SPDF, sharp principle diffuse fundamental. Are you seeing it now? And you, of course, this is what the letters stand for: sharp, principle, diffuse, fundamental. But now you now know that there is a shape for s orbital. There is even what we call nodal plane and nodal surface. We talk about where there is no probability of locating an s electron nodal surface, where there is no probability of locating p electron nodal plane. But please don't worry. Just keep those one aside. I told you when we are in this media space, me particularly, my mouth doesn't have break. I have to just point, even whether the one There's nothing that is above you. Take note of that. You have, you can, all this is at simple. Yeah, simple. You just need someone to point your attention to them so that you easily get adjusted on time. Now look at this. Look at this. The shape of S orbital is spherical. S orbital is spherical. All these things I'm going to do it. Let me repeat myself. I'm going to do them over again in atomic structure. So S orbital is spherical in shape. S is spherical in shape. Now P orbital now. P is dumbbell, D is double dumbbell, F is compress. Don't worry, we are going to do it. But now look at, based on the concept of hybridization, you see this is going to be 1s2, 2s2, and 2p2. All these numbers stand for this one, energy level, 2, energy, 2, energy. Now, I want you to understand, just like in periodic table, you know that elements that belong to the same group have what we call same number of valence electron. And now chemistry defines valency as the bonding power of an element. Bonding power of an element. That is what valency is. So element that belongs to the same group have same number of valence electron or outermost shell electron. Now, those elements that belong to the same group is otherwise known as congeners. We call them congeners. Congeners on the board. Congeners. Yeah, meaning that belongs to what? The same group. Take note. But when element is of the same period is talking about energy level. Yes, period is energy level. Shells. The more the shell, the more the energy. Do you understand? So period, just like when we have sodium, you have something like this, have this, and have this. This 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 2, 10, then 1. That is sodium in the old electronic configuration. But you see now, if you want to represent sodium, you have to do 1s2, 2s2, 2p6, and 3s1. Are you seeing it? 3s1. So all these things. So I'm going to teach you this under atomic structure. Of course, I'm going to teach you. But today, since you are doing revision, I want you to understand something, that orbitals of same energy level is called degenerate orbitals. Degenerate orbital. By the way, someone would have asked me, what is even this so-called orbital? What is orbital? Orbital. Just like when we are doing physics. Today is the first time I'm sitting down to do this based on the position of my board. Today is Saturday anyway, though I'm in my office space. So, but I have to just, let's make it possible. Sorry, next time, it was crowded outside. That is why I don't want to feel distracted. And I want to just stay inside and record this video. So my board stand is directly on the ground. So I have to just manage. So please, bear with me. Bear with me. Bear with me. Now, I want you to understand, orbital is actually, just like when we talk about physics, we talk about field, force field, or non-contact force, otherwise known as force field. When we talk about electricity, talk about gravitation, talk about magnetism, and you see that non-contact force, by non-contact force, we're now using the term field. What is the meaning of that field? Field, you now say field is the region in space. The region is actually something imaginary. It is the region in space where electrical force, gravitational force, or magnetic force can be felt or experienced. Are you seeing it now? Now, what field is to this thing that we what field is to electricity, to magnetism, and to gravitation is exactly what orbital is to electron. What is an orbital, everybody? Orbital is no other thing than the region in space where there is a likelihood, meaning high probability of locating an electron. The region you can, as in the region in space where there is so much possibility of finding an electron. We call it what? Orbital. Of course, we have SPDF orbital, though it passed that, but this is just, SPDF is just the area that you'll be concentrating on in terms of your electronic configuration, because you know that S orbital have 2 electron maximum, P orbital have 6, D have 10, and F have 14. So as we proceed, of course, you don't forget that the shape of S is spherical, P is dumbbell, D is double dumbbell, as F is compressed or complicated in shape, meaning it does not have any conformed geometric shape. Sorry, just let's be on the sense side of the distance now. I'll mention what organic chemistry is, that is all about carbon. Forget, initially they were taking it to be the chemistry study of living origin, until a man in 18th century, 1828 precisely, a man known as Friedrich Waller synthesized what we call urea, which is organic in origin, from an inorganic substance known as ammonium cyanate. And since that time, scientists have been able to discover that, okay, organic chemistry is not just limited to living source, but can also be derived from the synthetic analog. Of course, synthesis is usually done in the laboratory. So I'm just saying this to say that, sorry, so I have to keep checking once. All right. Yeah. Yes, 5 bond arene possible. That is good. Carbon has valency of 4. You are doing well. Thank you very much. Please keep dropping more reaction to the video. Now, at least we have been able to say 1 or 2 things. I've been able to say 1 or 2 things, and it's time we actually push forward. Oh, good. I dropped my DCL. Oh, what? Where's my this thing to clean this board? Oh, okay. So please, based on hybridization, you see an electron will be promoted here to this P because they are of same energy level. And I say orbitals of same energy level are called degenerate orbital. I already mentioned that. Now, carbon undergo just 3 types of hybridization. Your sp3, your what? sp2, and your what? sp hybridization. Don't forget, for sp3, it is simply for carbon-carbon single bond. That is how I want to. It is a revision class. Don't worry, I will take more time. If it is teaching, I will tell you it's teaching. We are not going to spend that much time. It is for revision. Since we're in a revision session, know that every carbon-carbon single bond is sp3 hybridized. No, that is why so many people that will ask you, what is the hybridization of benzene? You just rush and say sp2. You fail it. You not get your answer is wrong. And I'm going to show you why. Anytime that you see a mixture of carbon-carbon single bond and carbon-carbon maybe at some point double bond, it is both sp3 and sp2 hybridized. Because I'm saying this to say that every carbon-carbon double bond, anytime you see carbon-carbon double bond, it is what? sp2 hybridized. Know this and know this. Now, the same thing, when you come to this, every carbon-carbon triple bond is what? sp hybridized. Now, tell me how someone will give you this. I want someone to drop the answer in the comment section. Look at this. Let me say this is hydrogen here. Hydrogen and hydrogen. Okay, so this is hydrogen, hydrogen, and hydrogen. Of course, even if I ask you to name this, it's very simple now. Some of it is complete. Don't add any hydrogen. You can see each of these 1, 2, 3, 4. 1, 2, 3, 4. So it's complete. And if you are to name, I will name, but you are going to answer my question. This is 1, 2, 3, 4, or 1, 2, 3. Numbering in either direction will give the functional group same position. So with that, this is simply our what? But 2 ion. That is boot 2. I'm going to teach you the concept of naming. Yes. See, just follow through and be consistent. And that is for those of you that maybe probably you want to be joining the live session, but I don't know how to reach out to me. Please do well. Send me message on WhatsApp on this. I will add you to a group so that you can always easily come up with us. So that is how it's going to be. That is how it's going to be. This is it. 37, then 7238. Do well. And in case I want you to tell me the type of hybridization you can observe or you observe in that given compound. You are done. So, okay. I'm still waiting for someone to make an attempt. The type of hybridization that we have in that particular compound. Nobody is saying anything here too. Is the question too difficult? Let me zoom it. You can see, you are seeing it very well now. This is a boot 2 ion. What is the hybridization that you can see there? What is the hybridization? Please tell me the type of hybridization for this compound. Very important for this. I know you can see it very well. It's boot 2 ion. Let me remove the DC. What type of hybridization do you see in this? And then you can now answer comfortably, what type of hybridization do you see in benzene? I'm going to drop the structure of benzene. I'm going to drop the structure of benzene so that you see what type of hybridization is this. Let me have this. I'll draw it out this way. Sorry. It's charging, bro. So please, what type of hybridization do you see here? So this is benzene. As you can see, what type of hybridization do you see? Nobody have given me an answer to that. Nobody have given me an answer to that. I've dropped benzene, I've dropped the other compound. So what type of hybridization do you observe there? Okay. All right. Let me just, because of our time, I want you to understand whenever you see a mixture, in fact, just know, you see, this is just like your tables of knowledge, that every carbon-carbon single bond is what hybridized, is sp3 hybridized. Every carbon-carbon double bond is sp2 hybridized, and every carbon-carbon triple bond is sp hybridized. So here you have carbon-carbon single bond. With that, the hybridization is here is sp3. While this is carbon-carbon triple bond, that make it sp. See, this is still single bond, sp3. So it is a mixture of sp3 and sp. So with that, you can't tell me that boot 2 ion is simply just sp hybridized. It is both sp3 and sp hybridized. Same thing, if they ask you the hybridization of benzene, you don't just go straight and tell them that benzene is what? sp2 hybridized because you are seeing double bond. No. Every carbon-carbon double bond, it is sp2 here, sp3 here, sp2 here, sp3 here, sp2 here, and sp3 here. You look at the type of double bond, that will lead me to, let me just tell you three basic things. I'm not going to be too serious about it. There is what we call conjugated double bond. Conjugated double bond, otherwise known as alternated double bond. That is this type of double bond. After a double bond followed by single bond, another double bond followed by single bond. So you say it is conjugated or alternated. Then another type of double bond, I said conjugated. Another type of double bond is what we call cumulated double bond. Cumulated. This one clusters at a point. For instance, you have carbon double bond and you have another one. So it clusters at a point. The double bond clusters at a particular carbon, just like we are seeing here. And if I say, imagine I just put here hydrogen and here hydrogen, put here now, okay, I will put this CH2 and put here hydrogen and CH3. Now this is what we call to name this compound 1, 2, 3, 4, 1, 2, 3, or okay, let me stop. Let me make it like boot. This is 1, 2, 3, and 4. So it become, of course, you start numbering from here to favor the functional group, become 1, 2. So you simply name it as boot 1, 2 diene. And I want you to know diene is an isomer of alkyne. Diene, this is an isomer of alkyne. Are you seeing it? Diene, this is it. Diene is an isomer of an alkyne. It used to occur as a question. It is an isomer of alkyne. Double bond twice is isomeric with what? Alkyne, which is triple bond. Let me put it, it's equivalent to triple bond. Let me put it that way. So we still have a lot to talk about. So know this. So when we talk about it, it is both anything benzene now is both sp2 or sp3 and sp2 hybridized. Take note of this. It's a JAMB question. Either JAMB asks you benzene or they ask you taurine. Either they ask you benzene or they ask you taurine. You should take note. So it's either they say benzene is what hybridized or they ask you taurine. You should take note of that. So it's very, 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 very necessary. Yes. So that when a question, I say I have a lot of questions. Since we are doing revision, you can see one of the questions we have here is asking us, that is a question they pick from characteristic of an organic compound. They say, which is a characteristic of an organic compound? A, they have high melting point and boiling point. That is not true, because you know the type of bonding you found in an organic compound, organic chemistry, is what we call the covalent bonds. So covalent bonds generally have low melting points and boiling point, unlike that of electrovalent or ionic bond. So you say they have high melting point and low boiling point. It's out of point because high melting point is not there, but low is actually okay. Now you say they have low melting point and boiling point. Are you seeing it? They have low melting point. Let me not say something yet. And D, they have low melting point and high. So C is actually our answer. C is actually our answer. Are you seeing it now? C is our answer. C is our answer. C is our answer to those kind of questions. Sorry. Okay. All right. Before we finally bring this session, because I've seen there's a little distraction here in terms of my network. My network is